Hi. For Map I in the Theme 14 booklet, I'm going to introduce another structure. Now this is one we've seen before. This is the important geological idea of an unconformity. Now you might remember that an unconformity represents a break in geological time, a gap in the record. And they can be found in a number of different ways. These are the three main types of unconformity. The first we call a disconformity. We might find an erosional surface. You can see there's an irregular surface there shown on that block diagram. And there are missing periods of geological time. Now it's quite a subtle one, that, and perhaps one we're unlikely to come across at GCSE. Far more common is the angular unconformity. Now this is called an angular unconformity because there's a difference in the dip between two sets of beds. So the older set of beds there have been deposited, then tilted, then eroded off at the top before younger beds get deposited on top of that. That really is quite a common structure. The final example we have here is what's called a heterolithic unconformity. This is where you have two rocks that are found together that can't form together. So you might have a metamorphic rock like a schist, for example, with unmetamorphosed sediments sitting directly on top of it. Or it could be something like a granite, again with sediments sitting on top of the granite that haven't been metamorphosed. Now, recognizing these on a map is fairly straightforward. There are two ways we can recognize this. Firstly, two sets of rocks have dip readings that don't match up with each other. So here, for example, the blue, brown and yellow beds dip at 65 degrees to the south, but those sort of cream coloured beds are only dipping at 18 degrees to the west. So there's clearly a big difference in dip between them. The second way to recognise unconformities on maps are where one bed cuts across another one. So here you can see we've got some horizontal grey beds that are cutting across the blue, the brown and the yellow beds that are underneath it. So unconformities are an important feature in geology, and they're also quite a distinctive feature on geological maps. Map I has got some unconformities. Look carefully at the dips, the directions and the amounts that are shown in this area. Can you identify where that dip changes? Can we also look for where we have a cross-cutting relationship, where one sedimentary bed is cutting across another one? We also have photograph I. Photograph I is taken at locality I, which is on the beach. Think about the significance of that photo. Think about where it is and also what you're seeing. This map also introduces another new idea as well. This is where we use geological maps to help us solve real geological problems. Like, for example, the location of a waste disposal site, a landfill site, at the location marked Z on the map. You'll be asked to evaluate whether that's a good location. Okay, have a go then at question 9. See what you can come up with.